Right, so this last one in the tangent table at 3 pi over 2, which is right down here, is negative 1 divided by 0, which was undefined. Right, so let's get our graph set up. Again, this is theta. This represents tangent of theta. And every other, we will make a, one of the 4 corners on the unit circle. So, of course, this is 0. This is pi over 2. This is pi, 3 pi over 2, and 2 pi. And so halfway represents our pi over 4s. Okay? And I'm going to do this the same thing going the other way. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And of course we have our pi over 4s at the halfway part. Well, if you'll notice, anywhere where it says undefined, I want to draw an asymptote. So at negative pi over 2, and at pi over 2, and at 3 pi over 2. So if you notice that all my odd multiples of pi over 2, that's where I have an asymptote. So I have a feeling if I had gone negative 3 pi over 2 up to here, that would also have been 1 divided by 0 undefined. So I can also put an asymptote there. Okay, so let's go through and let's start graphing these points. At negative pi over 4, I'm at negative 1, which is right here. At 0, I'm at 0, and at pi over 4, I'm at positive 1. And then if I was to connect those, I am going to have a curve, and it looks like this. And notice my curve is going to get closer and closer to that asymptote. Same thing here, it's going to get closer and closer to that asymptote. And if I use my colors, remember green is quadrant 1, going from 0 to pi over 2. So from 0 to pi over 2, this is going to be green. Then, keep going in my table. Well, we can talk about what color this would be. This is going this direction, which is my pink, or quadrant 4. So that would be here that I'd have so far. All right, now let's go on to at 3 pi over 4, which is at that halfway point. I'm at negative 1. At pi, I'm at 0. And at 5 pi over 4, I'm at positive 1. So once again, I have that same curve. And let's again look at our colors. Blue represents quadrant 2, which goes from pi over 2 to pi. So from here to here, this is my blue, or my quadrant 2. And then from pi to 3 pi over 2, that'll be my yellow. So I think I see the pattern that I have here. I think I'm starting to realize that I'm going to have these curves. And these curves that go like this. And I can even figure out then my colors, because it just keeps alternating. Green, blue, yellow. This would have to be pink. Going backwards, I have pink, then I have yellow, then I have blue, and I have green. Notice that my green and yellow is always on above my x-axis, and my pink and blue is always below my x-axis, which makes sense Green and yellow is where tangent is positive. Pink and blue is where tangent is negative. So my pinks and blues are below, my greens and yellows are above. So that's my tangent graph. So let's talk a little bit about all of our trig functions. Let's talk about cosine. So when we're talking about cosine, it would be easiest if when we do this, we could be looking at the cosine graph. So what I've done is I've gotten this table, and I'm going to have us looking right here at the cosine graph while we answer these questions. So let's think first. Domain, remember domain are my x values. And when I look at my cosine graph, it looks like it's going to just keep going forever and ever in both directions. So as far as left to right is concerned. And so the domain is all reals. The range, which are my y values, are definitely limited. They never go above 1 or below -1. So I can use bracket notation from -1 to 1. Or I can use an inequality, y is greater than or equal to -1, less than or equal to 1. Period means how long does it take before the pattern repeats. And so I look at my graph, it started right here, and it makes this full U, and then it would repeat. You can see this right here, where I have all 4 colors in the before the pattern repeats. I end up with, it's really not looking at the colors as much as the pattern. I have a U, and then the U repeats. Every time I have a U, it takes me a full 2 pi. I have to go all the way around my unit circle before the pattern repeats. So the period is 2 pi, how long it takes before the pattern repeats. You might want to write that down. Period, how far on x-axis before pattern repeats. So if you look, it takes, starting here at 0, I do a big giant U, and then when I hit 2 pi, it would now repeat and do that U again. The relative minimum, the minimum value here is -1. The relative maximum is +1. X-intercept. Well, it crosses the x-axis on this particular graph 4 times, but this goes on forever and ever. This U is going to just keep repeating. I'm going to keep drawing, what I'm doing is I just keep going around my unit circle over and over and over again. And every time I go around, it hits the x-axis, I get a y value of 0, and all my pi over 2's. But how do I say that? Because technically, this is 2 pi over 2, and 2 over 2 is 1. This is 4 pi over 2. But it's at if you look at this is 1 pi over 2, 3 pi over 2. The next one would be 5 pi over 2, then 7 pi over 2, then 9 pi over 2. It's all my odd multiples of pi over 2. Y-intercept, it only crosses the y-axis 1 time right there at 0, 1. And asymptotes, the cosine graph has none. All right, let's move on to sine. When I look at my sine graph, let's see if I can get all that on the screen for you. Okay, when I look at my sine graph, the domain, again, this curve just keeps on going, so it's all reals on the x. And once again, I don't go beyond -1 and 1, so that's my range. or I can write it as an inequality. The period starts right here. This curve goes up, comes back down, and then it would repeat. So once again, to get a full sine curve in before the repeating pattern, it takes 2 pi. The relative minimum, the lowest value is -1, and the highest value is 1. X-intercepts. -2 pi, -pi, 0, pi, 2 pi. Then it would be 3 pi, then 4 pi, then 5 pi. So we're going to call that integer multiples of pi. And where is the y-intercept? Right there at 0, 0. And once again, I have no asymptotes. Now let's look at our tangent graph and do the same thing. So for my tangent graph, my domain, well, I can't say all real numbers because I have all these asymptotes here. And so x has asymptotes at all my odd multiples of pi over 2. Notice 1 pi over 2, 3 pi over 2. The next one would be 5 pi over 2, then 7 pi over 2, then 9 pi over 2. So x cannot equal odd multiples of pi over 2. Okay? All right, so next, sorry, I want to scoot that up so you can see all of this. The range, well, it goes forever and ever up and forever and ever down, so all reals are the range on the tangent. Now the period actually is not 2 pi. You notice we have asymptotes and this curve. Even though they're in certain quadrants, that doesn't matter. This pattern repeats. And from -pi over 2 to pi over 2 is 1 full pi. So everything repeats every pi. And you can look at it. You can see, when do I have the this curve? Here it goes through -pi, here it goes through 0, here it goes through 1 pi, then it goes through 2 pi. It repeats every pi. So the period for tangent is simply pi. It does not have a relative min or max because it goes on, it goes to infinity or negative infinity, so there is no relative min or max. X-intercepts crosses the x-axis at all my integer multiples of pi. And my y-intercept is 0, 0. Asymptotes are at x equals the odd multiples of pi over 2. Okay. So again, I want you to notice the biggest difference with tangent from sine and cosine is that that period repeats every pi. These curves only take 1 pi, and then you have another curve. And that pattern repeats every pi. And we have asymptotes at x equals the odd multiples of pi over 2. So I'm going to do periodicity theorem and the examples on the next page in the next video.